And let's go back to the whiteboard and we're gonna do one example here today. So here's my statement that I wanna prove. Prove that the following are equivalent. So we're gonna have 4 things to prove in this case. First of all, n is even. Secondly, n plus 1 is odd. Third, 3n plus 1 is odd. And fourth, 3n is even. So this is the following are equivalent that I'm looking to prove. 4 statements that I have in this case. N is even, n plus 1 is odd, 3n plus 1 is odd, and 3n is even. So for my proof, I am going to draw a picture and we'll decide where we want to put the arrows in. So 1, 2, 3, 4. How do you want to do the arrows? Somebody give me a suggestion and we'll go with it. This is an easy enough proof that I think I'm okay based on your suggestions. So somebody give me an arrow that I want to put in here. If I've got 1, 2, 3, and 4, we're going to need to come up with an arrow diagram that lets us get from any number to any other number. So somebody unmute yourself, be brave, volunteer, and give me an arrow that you want to draw in this first place. I can wait. Be brave. Oh, Grace, go ahead. Where do you want to draw an arrow?
1 to 2.
1 to 2. Okay, so we'll draw an arrow in there from 1 to 2. So that means I need to prove from 1 to 2. Somebody else, where else would you like to draw an arrow? Somebody else give me another one. Where do you want to go? Josh, you had your hand up. If you were going to say 1 to 2, that's okay. Or you can give me another one. Josh?
2 to 4.
I'm sorry?
2 to 4.
2 to 4. Okay, we can do that one. That's not on my piece of paper, but I feel confident that I can do from 2 to 4. All right. What else? Give me another arrow. Where else do you want to go? We can do this with 4 arrows. Let's see if we can do it with 1 to 2, 2 to 4. Where else would you like to go? Next one up. Somebody else give me another one here. Where do you want to go? Can you complete the diagram with 4 arrows? What's the next one? What do you want to do? Lauren, Grant, Alyssa, be brave, volunteer. What do you got? Alyssa. You're muted, hang on. There you go. And now I can't hear you even though you're not muted. You can do it in chat if you want to, from 4 to 3. Okay, from 4 to 3, we can do from 4 to 3. And then last, if I'm gonna finish, I can do from 3 to 1 and that will get me all the way around my picture. So this one has 4 proofs that I'm gonna have to do. Everybody good? Has 4 proofs. We're gonna do 2 of them together and then I'm gonna put you into breakout rooms and you can do the other 2 separately, I think. We'll try it this way. So let's start with 1 to 2. So here's my whiteboard arrow. So proof part 1 from 1 to 2. So in this case, I get to assume that n is even, and my need to show is that 3n plus 1 is odd. I'm very clear on that one from 1 to 2, except that's wrong because that's 1 to 3. Let's try again. Sorry. Let's do assume that n is even, and I need to show that n plus 1 is odd. There we go. That's better. Thank you. So assume that n is even, and I need to show that n plus 1 is odd. All right, you guys should be good at this. I'm gonna write it on my whiteboard without talking. Write it on your piece of paper. You guys are good at this. This is a totally basic proof. Take a minute, write it out. I'll write it without any talking. Pretend that you're sitting in class and see if you can get this one. This is a nice, easy one, promise. Okay, I think Josh is finished and Alyssa is finished and maybe Grant is finished and Grace might be because she's looking up and Lauren is just about, we're good? Everybody good? Give me a thumbs up. We're good on this one. Grant has a question. Yes.
So when do we use the therefore statement? Do we use it like only once at the very end, or like if we were proving like multiple things, we use it at the end of each?
I think I would probably use it at the very, I think I would go here, I would put a therefore statement. So we would say therefore n plus 1 is odd as desired. And then if you have a bunch of therefore statements, I would probably do a hence at the very end. You could do a therefore again too if you wanted to, but hence kind of indicates this big weighty thing that we finally finished up and now you're all ready to go. That said, if you don't put a therefore after every single part of the proof, that's okay. It's not the end of the world. Okay, we're good on this one. Give me a thumbs up. Everybody's good? This one's easy, no problem? Cool. Okay, all right, let's do proof part 2. So proof part 2, I think I can fit it on the whiteboard here. Proof part 2. Oops. So for my proof part 2, I need to do 2 implies 4. So for this one, I get to assume that n plus 1 is odd, and I need to show that 3n is even. To be clear on that one, if I'm doing 2 to 4, I get to assume that n plus 1 is odd, and I need to show that 3n is even. Are we happy? We're happy there? Okay. All right, so we'll talk through this one. Because n plus 1 is odd, we know that n plus 1 is equal to 2b plus 1 for some b living in the integers, and I need to show that 3n is equal to 2 sailboat for some sailboat living in the integers. Okay, so we know that. I'm gonna run out of space and that's okay. 3n equals, I'm gonna need to do a little bit of rearranging here. So 3n equals 3 times a little jump, but nothing big, 2b plus 1 minus 1. The n plus 1 is 2b plus 1, right? But I wanted an n inside of here, so we've got 2b plus 1 minus 1, n plus 1 minus 1. And then it just simplifies and falls out. So this is going to be 3 times 2b, or 6b, or 2 times 3b, which is 2 sailboat. So just a little bit of rearranging that we needed to do inside of here. This part, the 2b plus 1 minus 1, is really n plus 1 minus 1, which is just equal to n. So we need to do a little tiny bit of rearranging there. Okay, and then I need to keep going. Sorry, so we'll go up here. Where sailboat equals 3b, which lives in the integers, because you should be hearing my voice on a track in your head at this point in time. B lives in the integers, and we are using multiplication. And so we can say, therefore, in this case, we have 3n is even as desired. Yay. Okay. Any questions on the part 2 of the proof? Are we good to go there? Proof part 2? Everybody's happy? Everybody good? Okay. Make sure that you have, actually, let's do parts 3 and 4. Let's write them down. So proof part 3 is going to be, so proof part 3 is going to be, I need to move you. 4 implies 3. So proof part 3 is 4 implies 3. And then proof part 4 is going to be 3 implies 1. Do we see where both of those are coming from? Proof part 3 is 4 implies 3, and proof part 4 is 3 implies 1. Give me a thumbs up if you see where both of those are coming from. Good, yes, happy, thumbs up. Okay, I'm gonna split you into breakout rooms. I'm gonna stop sharing my screen. I'm gonna assume that you've got the following are equivalent, and I'm going to split you into breakout rooms. And we're gonna do guys and girls today just because. So, manually, 2 rooms. And I'm gonna have you do those 2 parts. So you've got 2 parts that you are working on, and I'll pop back and forth between you 2 breakout rooms. Okay, everybody ready? Here we go. I'm opening up rooms and you should get invites. Hopefully.